Hello students, today I am going to teach continuity and differentiability. Before starting the problems, first I explain basic concepts. See, first here we define continuous function. Definition: a function f of x is said to be continuous at x is equals to a of its domain. See here, first condition, f of x is defined. F of x is defined at x is equals to a. Then limit x tends to a, f of x is equals to f of a. Say these two cases are satisfied. The function is continuous. Say in another form, thus the function is continuous at x is equals to a if f of x is defined. F of x is defined at x is equals to a, and limit x tends to a minus f of x is equals to limit x tends to a plus f of x is equals to f of a. We say the function is continuous. Suppose the function f of x is not continuous at x is equals to a, we say the function is discontinuous at x is equals to a. When the function is discontinuous, here arise few cases. See, first one, f of x is not defined at x is equals to a. First case. See here, second one, limit x tends to a, f of x is not exists. Limit x tends to a, f of x does not exist. Next, third condition, limit x tends to a, f of x exists but not equal to f of a. Limit x tends to a, f of x exists but not equal to f of a. Say we say the function is discontinuous at x is equals to a. Here arise three cases. First one, f of x is not defined at x is equals to a. Next, limit x tends to a, f of x does not exist. Does not exist means, suppose left hand limits and right hand limits are equal, but not, left hand limit and right hand limit exists but not equal. That is second case. Next, third case, limit x tends to a, f of x exists but not equal to f of a. So next, derivative of f of x or differentiable. A function f of x is said to be differentiable at x is equals to a of its domain. Limit x tends to a, f of x minus f of a divided by x minus a. Exists and is finite, and it is denoted by f dash of a, is called derivative of the function at x is equals to a. Next, thus the function is differentiable at x is equals to a if limit x tends to a minus f of x minus f of a divided by x minus a is equals to limit x tends to a plus f of x minus f of a divided by x minus a is equals to f dash of a. These are respectively called left hand derivative and right hand derivative and are denoted by L of f dash of a and R of f dash of a. Okay, now here we discuss the problems. See, for the first one, let f of x is equals to sine pi x divided by 5x, x is not equals to 0, k x is 0 if f of x is continuous at x is equals to 0. Then the value of k is, see here we have the data, f of x is continuous at x is equals to 0. See, when the function is continuous means we know the definition, limit x tends to a, the function is defined at x is equals to a Another one is limit x tends to a, f of x is equals to f of a. Now here using that result definition, here we have limit x tends to a. Here we have in the place of a is 0. F of x is equals to, we can write f of 0. Or say limit x tends to a, f of x is equals to f of a. Now here we have a value is 0. Now here we substitute 0 in the place of a. X approaches to 0, f of x is equals to f of 0. Now here in the place of f of x, here we have sin pi x divided by 5x, and x is 0, f of 0 value is k. Therefore this result can be written as limit, substitute f of x result. F of x is sin pi x divided by 5x is equals to f of 0, x is 0, f of a, say a is 0 here, therefore this result is k. Now here we have the function limit, left hand side, limit x approaches to 0. Since the result x approaches to 0, sin pi x divided by 5x, now here we substitute 0 in the place of x. We get sin of pi into 0, sin of 0 is 0, divided by, here also we have 5 into 0, means here we substitute 0 in the place of x. Already we discussed this type of functions in the limits chapter. Now here we consider directly x approaches to 0, means substitute 0 in the place of x. Sin of pi into 0, see 0, sin of 0 is 0, divided by 5 into 0 is 0. See here we get 0 by 0 form in left hand side. Okay, see we get 0 by 0 form. Here we apply L'Hospital rule. L'Hospital rule states that derivative of numerator. See, derivative of numerator is limit. See, otherwise we have one more form. This result convert into standard result form. Means sine of x. We have this result. You can use apply L'Hospital rule. See, first here we apply L'Hospital rule. Limit x tends to 0. Derivative of this result is cos of pi x into derivative of pi x is pi x. The derivative of x is 1 into pi is pi. Denominator derivative of 5x. 5 into derivative of x is 1. Here we get 5 is equals to right hand side is k. Now here x approaches to 0, means substitute 0 in the place of x. We get cos of 0. Cos of 0 is 1. See here cos of pi into 0 is 0. Cos of 0 is 1. 1 into pi is pi, divided by denominator is 5 is equals to k. Means k is equals to pi by 5. This is the required solution. Here we have option A is correct. So this is L'Hospital form. We can try in another way. We know the standard result, sandwich theorem result form. Limit x tends to 0, sin x divided by x is equals to 1. Now here using this notation, now here we have this result. Limit x tends to 0, sin pi x divided by 5x is equals to k. Now here sin x divided by x, but now here we have in the place of x is pi x. Now here denominator result convert into pi x. See, sine of this x and x, both results are same. Here we get 1. Here also we consider, means we convert this result. Here we have pi x. Denominator is also converted into same notation, pi x form. Now here multiplied and divided by pi. In this result, multiplied and divided by pi. Therefore this result can be written as limit x tends to 0, sine pi x, denominator here 5x into pi. I write this result is pi x, remaining value is pi by 5, right, separately into k. Now apply limit x approaches to 0. Here we get this result is 1. See, this result is 1 into pi by 5 is equals to k. K is equals to pi by 5. See, here also we get same answer. Option A is correct. So here we have example. If f of x is equals to 1 minus cos x divided by x, x is not equals to 0, k x is equals to 0 is continuous at x is equals to 0. The function is continuous at x is equals to 0. Here we use definition limit x tends to a, f of x is equals to f of a. Here a is 0, we can write directly limit x tends to 0, f of x is equals to f of 0. This implies limit x tends to 0. Here we have f of x function 1 minus cos x divided by x is equals to f of x at x is 0, means at x is equals to will be 0 is equals to, here consider f of 0 is k. Now here x, since x approaches to 0, here we substitute 0 in the place of x, we get 1 minus cos of 0 is here cos of 0 is 1 divided by, here we have 0. See, 1 minus 1 divided by 0 is equals to 0 divided by 0 form. See, this is indeterminate form. See, given result in the form of an indeterminate form, here we apply L'Hospital rule. See, L'Hospital rule states that derivative of numerator. This implies limit x tends to 0, derivative of numerator value. See, derivative of numerator can be written as 1 minus cos x. d by x of 1 is constant term is 0. Derivative of cos x is minus sin x. Minus into minus plus sin x divided by derivative of x is 1. See, is equals to k. See, next step here, x approaches to 0, sin x is equals to k. Now substitute 0 in the place of x. We get sine of 0. Sine of 0 is equals to k. This implies k is equals to sine of 0 is 0. K value is 0. Here we have option A is correct. So to solve this continuity function, here we have f of x is equals to sine 5x divided by x square plus 2x, x is not equals to 0, k plus 1 by 2, x is 0, is continuous at x is equals to 0, then the value of k is, see, here we have the data, function is continuous. Function is continuous means we use definition limit x tends to, here we have a is, you can write directly, at x is 0, means a value is 0, at x is equals to 0, limit x approaches to 0, f of x is equals to f of 0. Now here, this implies limit x tends to 0. Now substitute the value of f of x. Here we have f of x is sine 5x divided by x square plus 2x is equals to f of 0, x is 0. We have the value k plus 1 by 2. Next step. See, x approaches to 0. X approaches to 0, substitute in the place of, substitute 0 in the place of x. We get sine of 0 is 0 divided by 0 form. Now here, this result can be written as split into standard notation form, limit x tends to 0, sine, here we have 5x. Denominator, here we have x square plus 2x. Here x is highest common factor. Here we can take x into 1 divided by x plus 2 remaining value. X into x plus 2, we get x square plus 2x. Now here, here we have 5x. See, now denominator is also converted into 5x form. Now here multiplied and divided by 5. Here we get 5x. See, 1 into 5, here 5. See, now apply limit to left hand side result. We get, see, x approaches to 0. This value is 1 into, see, substitute 0 in the place of x. Therefore, this result can be as 1 into 5. 1 into 5 is 5. Again, this result is 1. 1 into 5 divided by x is 0. 0 plus 2 is 2 is equals to k plus 1 by 2. Now, this implies 1 into 5 is 5. 5 divided by 5. 5 divided by 2. 5 by 2 is equals to k plus 1 by 2. Now, this implies k. See, now here 1 by 2. This result take to left hand side. We get minus 1 by 2. K is equals to 5 by 2 minus 1 by 2. Next, take LCM is 2. See, 5 minus 1 is equals to 4 divided by 2. See, 2 ones are 2 twos are, here we get the result value is 2. See now, check that options. Option A, value is 2 is correct answer option. See here, we have the function, the value of f of 0 means at x is equals to 0. So that the function f of x is equals to 2x minus sin inverse x divided by 2x plus tan inverse of x is continuous at each point of its domain. See now here the function is continuous. Here also we use same definition. Limit x tends to 0. Here we have f of x 2x minus sin inverse of x divided by 2x plus tan inverse of x is equals to f of 0. See now here we have to find the value of f of 0. See next step, x approaches to 0. See, x approaches to 0 means here we substitute 0 in the place of x. We get 2 into 0 is 0 minus sin inverse of 0 is 0, whole term numerator is 0 divided by 2 into 0 is 0 plus tan inverse of 0 is 0. Here we get 0 divided by 0 form. See, we get 0 by 0 form, we can apply L'Hospital rule. See, L'Hospital rule states that derivative of numerator, derivative of denominator. Derivative of numerator, what happens? 2 into derivative of x is 1. Here we get 2 into 1 minus derivative of sin inverse x is 1 divided by root of 1 minus x square divided by 2 into x is 1 plus derivative of tan inverse x is 1 divided by 1 plus x square. See, you apply L'Hospital rule, we get some result. Since otherwise you can divide both numerator and denominator. See, we know this standard result. Limit x tends to 0. Sin inverse of x divided by x is equals to 1, or similarly x tends to 0, tan inverse of x divided by x, this value is also equal to 1. Here we use this standard results form, convert into this format of this results, apply, this result is 1, and similarly tan inverse of x by x is also 1. Or we follow indeterminate form, apply L'Hospital rule to left hand side result form. Here we get derivative limit x tends to 0, derivative of 2x, here we get 2 minus derivative of sin inverse x is 1 by root of 1 minus x square divided by derivative of this result 2 plus 1 by 1 plus x square. See, is equals to f of 0. Next, x approaches to 0 means substitute 0 in the place of x. We get 2 minus 1 divided by root of 1 minus 0 square. 0. 1 minus 0 is 1. Root of 1 is 1. You can write 1 divided by 1. I write directly this result. 1 divided by, here also same, 2 plus x is 0 means substitute in 0 in the place of x. We get 1 plus 0 square is 1 plus 0. 1 plus 0 is 1. 1 divided by 1 is 1 is equals to f of 0. This implies f of 0 is equals to 2 minus 1 is 1 divided by 2 plus 1 is 3. F of 0 is equals to 1 by 3. See, this is, here we applied L'Hospital method, we get this result 1 by 3. Suppose here this result converted into standard notation form. We try in another form. See here, this method, both numerator and denominator divide by x, we get limit x tends to 0, divide by numerator, divide both numerator and denominator by x, 2x divided by x, we get 2 minus sin inverse of x divided by x, divided by numerator and also denominator 2 plus tan inverse of x divided by x is equals to right hand side value function f of 0. Next, here apply limit both numerator and denominator means f of x divided by g of x form. X approaches to 0 means substitute 0 in the place of x. 2 minus limit x tends to 0 sin inverse of x divided by x, this is standard result, value is 1, divided by 2 plus derivative of limit x tends to 0 tan inverse of x divided by x, value is 1 is equals to f of 0. This implies f of 0 is equals to 2 minus 1 is 1 divided by 2 plus 1 is 3, 1 by 3. This is convert into standard notation from this result. Here we apply El Hospital rule. And answers are same. Option, here we have C is 1 by 3 is correct option. See here we have function x square minus of a plus 2 into x plus a divided by x minus 2, x is not equals to 0, 2, x is equals to 2 is continuous at x is equals to 2, then the value of a is. Option A is 1, option B is 0, option C is minus 1, option D is 3. Now here, function is continuous. When the function is continuous, here we use definition, limit x tends to, here a, in the place of a, here we have 2. F of x is equals to f of 2. F of x is equals to f of 2. This implies, now here we have f of x result. See now this result can be written as the limit x tends to 2. F of x is x square minus of a plus 2 into x plus a divided by x minus 2 is equals to f of 2. See x is 2, the value is 2. See now I consider directly f of 2 is 2. Next, here x approaches to 2. See x approaches to 2, here we have numerator and denominator. X approaches to means substitute 2 in the place of x. 2 square is 4. I write here 2 square is 4 minus of a plus 2 into x is 2 plus a whole divided by x is 2, here 2 minus 2, 0 is equals to 2. Don't write this undefined form because here because f of x divided by g of x, we can take cross multiplication form. I consider directly this result is 0. I take cross multiplication this term. 0 into 2 is 0. See a, simplify the result. 4 minus a minus 2. See otherwise multiplied by 2 into this term. Directly here we get minus 2a minus 2 into 2, 4 plus a is equals to 0. Next step. See here we have positive and negative plus 4 and minus 4 gets cancelled. Here we have minus 2a plus a is equals to 0. Next, minus 2a plus a, here minus a is equals to 0. This implies a is equals to 0. The value of a is 0. Option, here we have B is the correct option. So here we have function f of x is x to the power 5 minus 32 divided by x minus 2. X is not equals to 2. K x is equals to 2 is continuous at x is equals to 2. Then the value of k is. See now here the function is continuous. We use the definition limit x tends to a. Here a is 2. F of x is equals to f of 2. Same as it is a previous form at x is equals to 2. This implies limit x tends to 2. Here we have f of x. Substitute the result x to the power 5 minus 32 divided by x minus 2 is equals to f at x is equals to the function is k. Next, since x approaches to 2, we substitute 2 in the place of x. We get 2 to the power 5 minus 32 divided by 2 minus 2. See 2 to the power 5 value is 32. 32 minus 32 is 0 divided by 0 form. See this is indeterminate form. Here we can apply El Hospital rule. Now apply El Hospital rule. This implies limit x tends to 2, derivative of numerator 5x to the power 4, derivative of constant term is 0 divided by derivative of x is 1 is equals to k. Next, x approaches to 2 means substitute 2 in the place of x. We get this implies 5 into 2 to the power 4 is equals to k. This implies k is equals to 2 to the power 4 value is 16. 16 into 5 is 80. K value is 80. Option B is correct answer. So here we have the function f of x is equals to sine 3x divided by x. X is not equals to 0. K divided by 2 x equals to 0 is continuous at x equals to 0. Then the value of k is. Now here we have the data. The function is continuous. Here we use definition limit x tends to 0, f of x is equals to f of 0. Say limit x tends to x approaches to 0 f of x. Here we have f of x function sine 3x divided by x. This implies limit x approaches to 0 sine 3x divided by x is equals to, at x is equals to 0, the function value is k divided by 2. See now here x approaches to 0, substitute 0 in the place of x, we get 0 by 0 form. We can use the L'Hospital rule form, or we know standard result, we get easily the form. See now here we have 3x, now here denominator x. Now this result denominator converted into 3x form, that's why here multiplied and divided by 3. See this form in the form of limit x approaches to 0 sin x divided by x form. See instead of x here we have 3x. Now this is standard form. Here we get 3 into 1 is equals to k by 2. This implies k is equals to 3 into 1 is 3, 3 into 2 6. K is equals to 6, option B. See otherwise you can use see 0 by 0 form, apply L'Hospital rule. See derivative of, see in this result, limit x tends to 0 sine 3x divided by x, see is equals to k by 2. See another method. See now using x approaches to 0, here we get 0 by 0 form. This is indeterminate form. Here we can apply L'Hospital rule. L'Hospital rule states that derivative of numerator, derivative of denominator. Derivative of numerator we get cos, limit x tends to 0, cos of 3x into 3 divided by 1 is equals to k by 2. Then x approaches to 0, substitute 0 in the place of x, cos of 3 into 0 is 0, cos of 0 is 1, 1 into 3 divided by 1 is equals to 1 into 3 is 3 is equals to k by 2. K is equals to 3 into 2 is 6. See you can use any form, use L'Hospital rule form or direct standard result. See option B is correct. So here we have the function. If f of x is equals to x square minus 10x plus 25 divided by x square minus 7x plus 10 for x is not equals to 5 and f is continuous at x is equals to 5, then f of 5 is. See here we have options. Now here we have to check which option is correct. Now here using the function is continuous means here use definition, limit x tends to a is 5, x approaches to 5, f of x is equals to f of a is 5, f of 5. See now this implies, here we consider limit x tends to 5, here we have f of x function, x square minus 10x plus 25 divided by x square minus 7x plus 10 is equals to f of 5. Now here x approaches to 5, substitute 5 in the place of x. In this result x square means 5 square 25, 25 minus 10 into 5 is minus 50 plus 25 plus 25 plus 25 is 50 is minus 50 is cancelled. We get numerator 0, denominator x square 5 square, say 25 minus 35 plus 10, say 35 minus 35 is cancelled. We get 0 by 0 form. Say 0 by 0 form is an indeterminate form. We can apply L'Hospital rule. Derivative of numerator, limit x tends to 5, 2x minus 10 divided by 2x minus 7. Constant terms becomes 0. Derivative of constant term is 0, f of 5. Now here x approaches to 5 means substitute 5 in the place of x. We get this result, or 2 into 5, right directly, 10 minus 10 divided by 5, 2 into 5 is 10 minus 7 is equals to f of 5. This implies f of 5 is equals to 10 minus 10 is 0, 0 divided by 3 is equals to 0. F of 5, see f of 5 is equals to 0 by 3 is equals to 0. Here option A is correct. Option A is 0, B is 5, 10, 25. Option A is correct. Okay, thank you students. Remaining questions I will teach in next video.